Alright, today's lesson covers two sections, 11.4, 11.5, and the basic premise is about area and circumference. So those are the formulas we're going to get on this page. Let's start off with circumference. Does anybody know the formula for circumference? Okay, it's not pi r squared. Circumference equals 2 pi r. Another way to write that is circumference is, what's 2 times radius equal? Diameter. So you could have said pi times diameter. There's two formulas depending on which one you want to use. A lot of times I just use the top one, 2 pi r. Now a lot of you said the area formula for circumference, so you got it backwards. The area formula is good old pi r squared. So those you should already know from elementary school and Algebra 1, middle school as well. But now we're going to modify some things and add to it a little bit for arc length and area of a sector. So I'll draw a quick little picture. When you're finding length of arc, it's going to a central angle. So you're going to be using a central angle. So that means you will have an angle that goes to the center. And that length of arc is going to be that distance around the edge of the circle. That's what we're going to be trying to find. Its formula is in the form of a proportion. So it deals with the angle out of 360. So how big is this angle in comparison to the whole triangle? On the other side, we're dealing with the size of the circumference. So we're going to be dealing with the circumference formula. Now if I type in 2 pi times the radius, I'll get the total circumference. And remember, total will go on your bottom. So 2 pi r, that's the total circumference. The 360 was the total angle around the circle. So that kind of makes sense. The totals are on top and the partial pieces, the totals are on bottom and the partial pieces are on top. So the length you're actually trying to find is going to be up here. So length of arc. You could just say arc length. That's our formula for length of arc. Once again, it's partial over total. Partial over total. We're going to do a similar process for area. So once again, we're going to make a little visual. The angle is going to go to the center, except for we're finding the area of that little piece. If you think of it like a little piece of pizza, we're going to find how much area this little piece of pizza will take up. So its formula is going to be like a proportion. The right side from the other one is the same as the right side on this one. It's angle over 360. You're always going to have that part of the proportion that deals with angles. Any guesses at what the left side is going to be? Anybody guess what's going to be on the bottom? What's going to be on bottom? Pi r squared. Yeah, that's the total area. So you might want to make a little note. That's the total area. And what do you think is going to be on top? We're not dealing with arcs. Arcs are all over here. This side is arcs. This side is all about area. Area. So what's going to go on top? Area of sector. Good. Area of the sector goes up here. And remember, a sector is just like a piece of pie. Here's some examples that will enable us to use some of those formulas on that last page. Let's start off pretty simple. The first one says find the indicated measure, and it wants you to find the circumference when the radius is 11. Which formula should we use for circumference? 2 pi r. Good job. So circumference is 2 pi r. And we can go ahead and plug in what we know, 2 times pi times the radius. In my head, I know 2 times 11 is 22, so in my calculator, I would just type in 22 times pi and get my approximate answer. Now note, I did not use 3.14 for pi. We have good scientific calculators. We actually use the pi button. So type that in and tell me what you get. So for our final answer, we get 69.1, and we got to have units on this answer. What should our units be? Just plain old meters. When would we put meters squared for area? And when would we put meters cubed? Volume. Good job. All right, the next one wants us to find the radius when the circumference is 18. So the formula that deals with the radius and circumference is c equals 2 pi r, and we're going to substitute what we know. The circumference is 18, 2 pi r. Now we need to solve this, and there's a few different ways you can do it. What would be your first step? Yeah, I like that. You could divide by 2 on each side. This part you could do mentally. That way they cancel there. You're left with 9 equals pi r. But now what do? Divide by pi, yeah. So in your calculator, you can type in 9 divided by pi and give me that answer to the nearest tenth. 2.9. And units are yards. Another way you could have done that is just take that 18 equals 2 pi r and divide by parentheses 2 pi on each side. Since they're both multiplying, you can divide by them at the same time. So you do 18 divided by parentheses 2 pi and then close it out, you'll get the same answer. On this next example, they say the dimensions of a skateboard wheel are shown at the right. They're in millimeters. To the nearest meter, be careful. They want their answer in meters. How far does the wheel travel when it makes 35 revolutions? So you need to think about it right now. You need to think, all right, when this wheel starts here and it rolls and goes all the way around, how far did it go in one revolution? Well, yeah, in angles, that would be 360 degrees, but we want its actual distance, meaning we need to find its circumference when it goes around one time. How could I find its circumference? Well, you could use one of our two formulas. We could use 2 pi r or pi d. Which one do you want to use? Pi d is actually going to be faster since we know all the way across. So let's write that out. Circumference equals pi times diameter. And the diameter is when you add up all these pieces. So 20 plus 20 is 40. 40 plus 15 is 55. Type in 55 times pi. And give me a few decimals this time. Give me 3 decimals. 172.78788. All right, there's the circumference. But right now this is in millimeters, and that's only one revolution. How many revolutions do I need to actually do? 35. So I need to take this value and times it by 35. So 172.788 times by 35 should be a pretty big number. 6,047.58. But once again, this is still in millimeters, and we need our final answer in meters. How do we make that millimeter answer meters? Divide by how many? 1,000. Good job. We divide this by 1,000 to get it into meters. So when you divide that out, you get about 6 meters. Good job. On this next page, we have a couple other different types of examples. And now we're talking about arc length. And if you remember back, arc length dealt with that proportion. Once again, that proportion looks like this. You have your angle over 360. You have your arc length over the circumference. So I could use 2 pi r or pi d for that circumference. I would practice writing that down. You need to be familiar with that one. So we need to plug in what we can find on this picture into that formula in order to find arc length. So the first thing I would realize is I have arc length is our unknown. We'll call it x. On the bottom, we're supposed to do 2 pi r. Well, we are given our radius. It's 2. So I could do 2 pi times 2. And on the other side, we need our angle over 360. Do we know our angle? Yes, it's 88. Now your goal is to cross multiply. So you could do 2 times pi times 2 times 88, and then divide by 360. Alright, so when you cross multiply, you should get x is approximately 3.07. Now be careful. The length of the arc, what kind of units should I put on this answer? Just plain old meters. So it's 3.07 meters to go around the outside of that arc from A to B. Now we need to do this other one. Part B is very similar. I'll give you a little bit of time. See what you can do on that one on your own. On Part B, it's a similar process. I'm just going to change some of these values over here to make them match what's in this picture. Right now, we're trying to find the length of RS. So we could go R around to S this way or the other way. It doesn't matter because we're cutting the circle with a diameter. So what's the angle whenever you have a diameter? 180. So I can quickly modify that in our little problem. So that's now 180. Over here, we like to do 2 pi r. Let's try pi d this time. Since we know the diameter is 12.3, we can just do pi times 12.3. And now when we cross multiply, it's pretty easy. Pi times 12.3 times 180 divide by 360. What do you get for x whenever you do that? All right, when you do that, you get about 19 point something. However, we made a little find over here. This 12.3 is not the whole diameter. It's just talking about the radius. It's pointing at the middle of that piece. So really, you should do 2 times pi times that, and you'll end up getting 38. But some people just found that they already give you that. They say this distance over here is 38. Well, if it's 38 on this side, it's also 38 on the other side. So really, they gave you the answer on this one. That's kind of tricky. I didn't see that 38. I skimmed over it. Good job. All right, here's another one. This is a problem that's similar to what's on the ACT and what's on the test. So they say a conveyor belt for luggage on an airport is shown at the right. The outer part of the circle belt forms a 180-degree arc. So what it's talking about is that part right there, when you go around it, that's 180 degrees. Same thing down here on this end. I say the radius is 8 feet, and that's indicated over here. The 8 is pointing at the middle of that radius. Approximate the distance around the whole belt for a coin on the outer portion, round to the nearest foot. There's a few different ways we could do this. What I like to think about is we have a half circle down here, and we have a half circle that's the same size down here. Do y'all see that? And what happens when you take a half circle and a half circle that are the same size and put them together? You get one whole circle. So we can really just find the circumference on that circle when we stick them together. So circumference is going to be 2 times pi times a radius of 8. So in your calculator, you can type in 16 times pi and see what that gives you. I heard 50.27. That's for around the circular portion. But if we're going to go all the way around this conveyor, what do we also need to add in? We have a 20 here and a 20 here. So we've gone around the circle so far. Now we had 20 and 20 more. So let's write that out. The total is going to be 50.27 plus the 20, that's that straightaway, and another 20, which is over here. And we get a total of 90.27, and the units are in feet. Now we're ready for the area problems. Does anybody remember what the area formula is? Pi r squared. You should memorize that if you haven't already. Area equals pi r squared. So the first one's very easy. You just plug in the radius to that formula. So area equals regular pi times radius is 4.2, and then squared, just that 4.2. Type that in real quick, make sure you can get a good answer. If you don't have a good calculator, you probably can't square a number. That means you just multiply it by itself, though. Pi times 4.2 times 4.2. 55. 55.42. Are we in agreement? And the units on area are going to be units squared, so meters squared. The other one is a challenge problem for some people. This next one tricks a lot of people, but you got to be able to do this algebra. On this next one, they say find the diameter when you know the area. So think about your formula. Plug in what you know. We know the 201 for area. We know the pi. And radius squared is the piece that's a little bit different. Our goal is to solve for r in that equation. What's a good first step to solve for r? Divide by pi. That's a good first step. So 201 divided by pi, and give a lot of decimals. What do we get there? 6.980. Okay, that's good. That equals r squared. I just brought down the r squared. And how do you get rid of squaring a number? Good job. Square root both sides, and you'll be left with r equals 7.8, 7.9. What is it? 7.999. And make sure your units on it, those are inches. There's our final answer. Sorry, we forgot to finish the question. It says find the diameter. That means we need to double the radius. So take this and times by 2. So it's going to be approximately 16 inches for the diameter. So we didn't want the radius. We just used the radius to find the diameter. All right, this one down here, you see a little piece of pi. That means find the area of a sector generally. It's talking about areas of a sector. And that's exactly what the question says. Formed by RQS. So RQS, this 63-degree angle is going to be used. We had a proportion that we said we have to use on this type of problem. And in that proportion, do y'all remember what goes on the right? On the right, we don't have the area stuff. We have angle stuff. What angle stuff do I put over here on the right? Angle of the sector over 360. Well, we know 360 is easy. Do we know the angle of that sector? 63. Now on this left side, remember, we're dealing with area. So what could we fill out easily on this left side? Pi r squared, and where does that go? On the bottom. And we're lucky. We know our radius. It's 5. Pi 5 squared. And now we can cross multiply and solve for that unknown piece on top, the area of the sector. So on your calculator, it'd be smart to do pi times 5 squared times 63 and then divide by 360. 13.74. And that's area, so we put units squared. Always put units. If they don't give them, you put U. This next example is a little bit different. It says find the area of circle C, but they give you different information this time. We got to think back to our formula. I'll write it out. It might help you this time. So angle over 360 on the right. We have pi r squared on the bottom on the left. That will give us our total. And up here is the area of the sector. Area of the sector. We got to use what we know to plug into that formula. What could we plug in? Oh, we know the area of the sector. It's 22. That's a little bit different. We haven't seen that yet. Do we know anything else? Oh, we know the angle. Is that 45 or 46? 45. Now let's read the question one more time. Find the area of the whole circle. Does it say find R? So we really don't need that whole thing right there, because what does this represent? Area of the whole circle. So really we could just put A, since we're finding the area of the whole circle. That's what my total is. That's a commonly missed problem. People will go through and solve for R and then plug back in or make mistakes somewhere in the middle. This one's not that bad. So when you're cross multiplying this time, you'll do 22 times 360. And the other cross is A times 45. Divide by 45. And you'll get your area. 176 even? Awesome. So 176, and the area is in meters squared. All right, here's our last one. They say a contractor needs to cut a section out of a rectangular piece of wood as shown to the nearest square inch. What's the area of the remaining wood? We got to find the area of this shaded section. My advice is find the big area of the big board first. So the whole board, how do you find its whole area? Length times width based on height? Yeah. So to find the total area, what numbers do I use? 11 times 7 for our total over there. 11 times 7 is going to give us 77. But I need to subtract some things from that total. There any quick ones I can subtract out? Do y'all see these shapes up here? What shape is this on? Oh, it's 3 this way. How tall is it this way? Oh, yeah, transfer that 3 over. And 3 times 3 is, so subtract that little square, which is 9. And then we got to subtract this half circle. We got to find the area of that half circle. So I'm going to note that out here to the side. The half circle, we got to find its area. So area equals pi r squared is what we generally use. Do you know any measurements on that half circle? You know the diameter is 3. Can you use that to find radius? What's half of 3? 1.5. So the area is pi 1.5 squared. However, that's going to give me the area of the whole circle. I don't want the whole circle. I want half of it. What should I do at the end with that answer? So do all that and then divide by 2. That'll give me the area of that half circle right there. All right, when we do that, we get 3.53. So that's the other measurement I need to subtract out. So to get our final answer, we do 77 minus 9 minus 3.53. And what do we get when we subtract out all those values? We get 64.47 inches squared. That's our total after we make those cutouts.